See the next sum. Next is question number 5, which will make basic buffer solution. So it is talking about basic buffer solution. So C, basic buffer is defined as mixture of weak base and salt of weak base with a strong acid. So how basic buffer is defined? So it is defined as mixture of weak base and salt of weak base with a strong acid. Right, with weak base with salt of a strong acid. Right, so for first option C, it is given that CH3COH when react with NaOH, it forms CH3CONa plus H2O. Right, so before the formation, moles volume is 100, this is also 100 ml, so it is not formed, so it is 0. So molarity is given, that is 0.1 molarity. So multiply, then you will get 10 millimole. This is also forming into 0.1 molarity. So forming 10 millimole. So after forming the compound, so it will be remaining 0 and acetate ion, sodium acetate will be formed as 10 millimole. So salt hydrolysis is take place. So there is no not a basic buffer, right? Salt hydrolysis is happening here. Hydrolysis. So it is not basic buffer. Right. Now see the next option, second one. So for second acid is given HCl plus NH4OH. Right. So this is a strong acid. This is weak base. It forms salt and water. So it is forming NH4Cl plus H2O. So 100 ml HCl we have taken with the molarity 0.1. So multiply, you will get 10 millimole. So again 200 ml of NH4OH is taken, multiply with 0.1 molarity, it will form 20 millimole. Right. So after dissociation, what it forms? It is 0. It is 10 millimole we are consuming. So it will be formed as 10 millimole. So it is basic buffer. Why? Because here 10 we are consuming and 10 millimoles are remaining. So this is the remaining part and this is your consumed part. So this is your basic buffer solution. So right up to this point. Now let's see the option C for the same question. When HCl is react with NaOH, it forms sodium acetate CH3CONa plus H2O, right? So it is given 100 milliliter and it is reacting with 0.1 molarity of solution. So it is forming 10 millimole, right? In the similar manner, this is also 100 ml reacting with 0.1 molarity forming 10 millimole, right? So initially it is 0. So what will happen now after the reaction? It will be consumed and it will be formed 10 millimole. So no base is remaining there. So it is neutral solution, right? You can see this is a strong acid, strong base, right? So it is forming neutral solution. So now see the option D. So when acetate ion CH3COH react with NaOH, it forms acetate CH3CO Na plus H2O. So before forming, it is 25 ml reacting with 0.1 molarity. So it will be 2.5 millimole, and this is a 50 ml reacting with 0.1 molarity to form 5 millimole, right? So after the reaction, this will be consumed. So it will become 0 and this will be consumed 2.5. So 2.5 millimole is remaining, right? And this will be the 2.5 millimole. So it is basic buffer solution because it is remaining, right? So how much remaining? 2.5 millimole. So 2.5 millimole is basic buffer solution, right? But not a basic buffer. This is basic buffer, but it is not completely, right? Because this is a strong base. Now see the question number 6, solubility of barium sulfate. So barium sulfate solubility is given, that is S. Value is 2.42, 10 raised to minus of 3, 10 raised to 3 है. Then it is gram per liter at a temperature of 298 Kelvin. The value of solubility product it is asking about. So KSP is nothing but solubility product, right, will be given. So molar mass of barium sulfate is given, that is 233 gram per mole, asked in 2018. So let's see the explanation now. So for barium sulfate, when it dissociate, it forms Ba2 plus SO4 2 minus, right? So solubility product will become then concentration of Ba2 plus concentration of SO4 2 minus. So it will be S into S. So it will be become S square, right? So S will be the under root of solubility product. So it is given, that is that will be the S, right? So let's see the changes first. Solubility S is given, right? So S is, that is 2.42 into 10 raised to 3 gram per liter divided by barium sulfate. It is given by 233 gram per mole. So convert into mole per liter. So it will be divided by 233. So conversion will be 1.038 10 raised to of minus 5. That will be the mole per liter. So this will be the solubility. So finding the solubility product, that is S square. So square this quantity, that will be 1.038 10 raised to of minus 5 whole square. So it will be coming out to be as 1.08 10 raised to minus of 10, right? Mole square per liter square. This is the value of solubility product.